Okay, it looks like a difficult integral, and I want to put up the integrand here. Before I do anything, I want to make sure the domain of this is okay. All right, so the one thing is I know the natural log of x. The domain of this thing over here would be x would have to be greater than 0. And for the natural log of 1 minus x, the domain of this would be 1 minus x would have to be greater than 0. Let's just look at those two sets. And the first set I want to look at is, this one over here. And what do you get there? Well, it starts at 0, and it goes off to infinity, like this over here. Let me put the other one down. I'm going to put this one down now. And to do that, it looks like over here, it looks like this, which means x is less than 1. Whoops, I didn't mean to shade that in. So the domain of this integrand here is going to be from 0 to 1. Right. One thing you want to look at too is you want to look at the limits as you approach 0. Let me get my eraser out. Because really, this is a difficult issue here when we approach 0 and 1. But let's say, suffice to say, that you get your graphic calculator out and you graph this guy. And what you look at is you see a picture of it. All right, so I'm going to graph out f of x equals the natural log of x times the natural log of 1 minus x. And what you'd see over here, you see a picture that looks like this over here. All right? So I'm going to say, looking at the picture, you certainly don't see those big circles there. But, what are you looking at? You're looking at, a shaded region over here. And certainly it looks doable. It looks like we could do this. All right? So I'm going to say that looks doable. So what I start looking at is, how I would do the problem. And I always take the easiest approach. I'm going to get my eraser out. I'm going to erase this again. And what I would probably do is look at that, and it looks sort of like symmetric to me. So I'm going to make a substitution. And the substitution I'm going to make is I'm going to let u equal 1 minus x. And then du would equal minus dx. Well, I'm going to take the integral, and I'm going to just play around with it. And what's the lower limit going to be? At 0, this would be 1. And at 1, it would be 0. And then you can get the natural log. Well, I got to get what x is in terms of u. And let's take a look at that. X would equal 1 minus u times, 1 minus x is u, so a natural log of u. And then what do you get over there? Well, you get the dx is going to be minus du, so put it on the outside. Well, I'm just going to rewrite this a little tiny bit. It's the opposite of that integral, so I'm just going to change the limits of integration, 0 to 1. And I'm going to rewrite it a little bit differently. Natural log of u, natural log of 1 minus u du. All right, so I'm there, and I'm looking at that, and it surprisingly looks the same, doesn't it? So you can make another substitution. I'm done with this one now. And what I'm going to do is just make another substitution. I'm going to say u is equal to x. What does that mean? Du is equal to dx. And lo and behold, what do I get? An identical integral back. So that has been unsuccessful. What am I basically just showing? That this and this are identical. That substitution didn't help at all. All right, so I'm going to say by the u substitution, I'm in sort of like an infinite loop. If I kept doing that, I'd keep going back to the original integral. And you need to escape that loop. All right? So one thing you could do is you could try integration by parts. But I'm going to say, if you do that, you're going to get into trouble real quick. All right? I'm saying I don't think it's possible, but you could try it. And who knows? Maybe you get out of that loop quickly. All right? You're not getting out of this loop quickly, though. That's going to keep going and going and going. So what I decided to do was I decided to use Sage instead. All right? So when I use Sage, kind of typing it in, basically I defined a function, I plotted it out. Again, when you plot that, you get that picture we suggested before. I looked at the limits from both the left and the right. I put out what I mean by that. I looked at the limit, again, f of x is equal to the natural log of x times the natural log of 1 minus x. And I looked at two limits. I looked at the limit as x approaches 0 from the right side of f of x. And this turned out, using Sage, to be 0. You can do this by handwork, too, if you want. And limit x goes to 1 from the left of f of x, that also appeared to be 0. All right? So I'm going to say just the picture gives me that, Sage gives me that, and then I asked Sage, can you integrate it? And Sage was able to integrate it pretty quickly, by the way. And I came up with a number, came up with this number over here. And then I wanted to approximate that number, and I got this over here. Now, what I'm going to suggest to you here is that I can't claim that this can't be done by those techniques, but I think we need to wait until we see series to actually get this solution over here, all right? And we'll get there. Now, if you're in a rush to get there, you could jump to that page if you want. It's actually problem 16 on page 402. But there's material that comes between now and then that you need to learn before you go there. All right, now when you get there, there's going to be a link back to this problem as well. All right, thank you for paying attention.